Okay, so yesterday we only discussed the shell method when we had an axis of rotation that was either the x-axis or the y-axis. Well, what if I give you x equals 5 or y equals -2 as our axis of rotation, okay? Well, what is it going to affect? Is it going to affect the height of our shell? No, it's going to affect the radius, okay, which we've been calling x or y, except in number 16, and this will help you understand why 16 the way it is, and I didn't realize 16 was the way that it was. Okay, so when we set up our integrals, we have 2 pi times the radius times the height times the thickness. Okay, the thickness is always
dx or dy.
Thank you, Jimmy. The height, okay, f of x minus g of x, top minus bottom, right minus left. Okay, our radius is what is going to be affected. Okay, so look at that picture. Okay, if our axis of rotation is at x equals a, then what is our radius going to be? Well, in this case, okay, so if it was this, right, and we rotated it around, our radius was x, correct? Because any given rectangle was x away from our axis of rotation. So now it's going to be a, well, in this case, a minus x. For this particular picture, a minus x. Let's talk about it. Okay, the radius is going to be the distance from your radius to your any given rectangle, right?
Could you show like an example?
Here is our rectangle. If x equals 0, if the y-axis was our axis of rotation, its distance was x away, right? Well, now our radius is from here to here. So it is a minus x away.
So if it was a number like in x equals 5, we rotate it, that would just be 5 minus that?
Sorry, what?
Like if we're rotating around x equals 5, it would just be 5 minus that?
Okay, what happens when x is on the right side of the line? Then you're going to have to do, we still need to do this same thing of right minus left, top minus bottom. Okay, so it might not be a minus x all the time. It could be x minus a if a is on the left side of our y-axis. Okay.
What if I give you a negative?
Whoa, wait.
Oh, like you're talking about on like the second quadrant or whatever. Like
Okay, our height is still going to be. What? Oh, that's really what you said. That was a very fast number. Okay. We will do an example when our axis of rotation is on the right side, and we will do an example when it is on the left side. So you can see how we're still doing, we're still having a positive rate. Okay.
so if our axis is a positive line, which means our axis is at a negative line.
So what? Well, I'm trying to process the
If our
question.
axis is on like a positive x value, if our axis is on a negative.
Okay. So we have the region of 4 minus x squared. X is 0, y is 0. And we're rotating it about the line x equals 2. Okay, so 4 minus x squared, what does that look like? Good. But it's bounded by x is 0 and y is 0, so it's only that piece of it. Do you agree? Okay, what are we going to do with that? We're going to rotate it around. X equals 2.
Hey, we're back to the small one.
Yep. Okay, so we're going to get a funky shape. Okay, now, here is our reference rectangle. Notice how we have a vertical reference rectangle with thickness dx. We're going to get shells, right? With our shell method, we want 2 pi r h times thickness. Okay, now our height, that stays the same no matter what. Top minus bottom. What is our top function? 4 minus x squared. What's our bottom function? 0. So you can subtract 0 if you'd like, or you don't have to. And then our radius. How far are each of these rectangles from our axis of rotation? Okay, if we think of the distance, okay, still right minus left. These are all x away from here, so we're going to say 2 minus x.
Would be 2 minus y, though.
No, because we're still doing dx.
All of those are x away from the y-axis. And our limits are yes, 0 to 2.
So it'd be, if you're going about like a y equals 2 or something, then it would be like minus y.
Right. Yes. Not in that, this wouldn't be a good problem for that. But, like if this one was y equals 4, then it'd be 4 minus 1. Yeah. Okay? 40 pi over 3 is what Jimmy got. Can anybody confirm or deny Jimmy's answer?
Anyone second that?
Confirm. I second it.
Confirm. Okay. Excellent.
So if it was x negative 2, then it would be x plus 2?
Yes.
So your radius is from your reference rectangle to what exactly?
The axis of rotation.
So it'd be like from that rectangle to x equals 2.
Mhm. Mm-hmm. And since 2 is bigger, we say 2 minus x.
Because everything is technically 0.
Could we have just gone simple b, g, one, and
Made it a, okay. And that's what we're going to talk about here in a little bit. After I'm going to have you do a problem from your homework to practice this, and then we're going to take a problem from your homework and look at different methods. Okay? All right. The region enclosed by the x-axis, the parabola, blah, 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 is revolved around the line x equals negative 1 to generate a solid of revolution resembling a bundt cake. Okay. 1 week from tomorrow, ladies and gentlemen.
Equals 3x minus
That's our test, though. We have a test next.
That is our test.
Is there a test of the bundt cake? How much of it
Fun,
like?
fun.
Okay. 3x minus x squared. Okay. So we have an upside down parabola. If we factor out an x, we're left with 3 minus x. So we have zeros of 0 and 3. Okay. We want to rotate this about
What's your height, right?
x equals -1. So we get a Bunsky.
Unbalanced.
That is horrible.
It looks like a race car track.
With a bunt cake sitting on top of it. Okay?
Yeah.
So the shell method will let us avoid having to solve these in terms of y, which is nice because you really can't solve this equation to be in terms of y. So shell method, thickness dx, volume of shells 2 pi RH thickness. Okay, the height of each of those shells is what? 3x minus x squared minus 0, right? It's the height of those rectangles. I don't care if you put the minus 0 or not. And then our radius. Our radius is from each of these rectangles to the axis of rotation.
So X plus 1.
Okay, so this distance right here is x minus a -1 is what you can think of that as. So x plus 1 is our radius. Some of you might like to think of it as, well, this distance is x, and then I'm adding 1. That's fine too. But some of you like the right minus left, top minus bottom consistency.
I kind of like the idea of whichever number's larger, it comes first.
Mm-hmm. And that's the idea of right minus left, right? Yeah. Okay, so I'll let you type that into your calculator for me. Oh, where is it from? 0 to? No.
3.
3.
Aaron. There. 3. It's in.
Total.
45 over 2 pi. 45 pi over 2.
We can get it. What's this?
Excellent.
A lot of
All right. Last example, and then I'm going to make you do one of your homework problems. Okay, y minus 2 the quantity squared. That is a parabola opening to the right, and it's shifted.
right.
We would think of right 2 if this was y equals x.
11.
Right is positive, so up. And then we have this line, right? Y equals x.
Yeah. Yeah.
Okay. So here's our region.
We should use top minus bottom or right to left.
Well, let's talk about this. What is going to be the easiest if we have horizontal or vertical reference rectangle?
Oh, right to left.
Okay, because we're rotating it about y equals 1. We want right to left rectangles. Why, Jimmy?
Because it's parallel to what we're rotating.
Yeah, but aside from the fact that we've been learning the shell method, why would this be better?
Because it doesn't change.
Okay, it doesn't change. And if we had vertical reference rectangles, our top function minus bottom function would change partway through. We don't want two integrals. Okay, that's too much work. Okay, so this is going to be best. So since these are parallel to our axis of rotation, we're going to be creating shells. So 2 pi r h thickness, right? What is the height of each of those reference rectangles? And we get that because our rectangles, we take right function minus left function. Y minus 2 squared. Okay? Our radius is going to be y minus -1, or in other words, y plus 1. Okay? Y minus 1. Negative. Okay? Now, this we can tell is 1. What is this intersection? 4. Let me show you how to algebraically test that. I look at my graph. It looks like 4. Well, if 4 is y, that means x is 4. If 4 is y, y minus 4 minus 2 squared is 4. That means x is 4. Are those the same x values? Yes. So that is the intersection. If I got two different x values there, that was not the intersection. Jimmy says 63 pi over 2.
The crowd says
10 points.
no.
No.
Cashing in all my 10 points.
I got 126 pi over 4.
126 pi over 4. Oh, can you reduce that?
I didn't look.
Okay. You know your calculator can reduce fractions, right?
I never knew that.
Really?
I don't know, like,
Don't know how.
I only know probably 2% of what my calculator has.
Mine.
Okay.
Yeah. You can just be smart.
All right. So, Aaron, let's say you have 126 divided by 4. If you press math, fraction, it's going to give you a reduced fraction.
Oh.
If you have a decimal and you don't know what that is, if you go to math, fraction, it gives you a fraction. So this is what I'd like. This is your homework. I would like everybody to begin on number 23. I would like you to raise your hand and have me check your number 23. When everybody is finished with number 23, I'm going to pick another problem from our homework to do together.
You know, get candy? Yeah.
I don't know if I have enough candy for
Oh, you
everybody.
target